December 1944. Inside a dimly lit hangar on the edge of Rechlin. The air carried the smell of oil, metal, and quiet defeat. Germany was still in the fight, but every man in that room already knew how it would end. Under the glow of a single floodlight stood a huge engine crate, its markings faded and worn. Pratt & Whitney aircraft are 2800. It had been taken from the wreck of an American P-47 Thunderbolt shot down over northern France. The fuselage had been twisted and burned, but the engine, this massive round, 18-cylinder monster, had somehow survived. Touched technicians from the Luftwaffe's experimental division gathered around it like priests, preparing to open a sacred relic. They murmured among themselves. "So this is what powers their flying milk cans?" one muttered, using the mocking name German pilots gave to the P-47s. To them, the American fighter was a brute, heavy, slow-looking, and built in a way that went against every rule of elegant engineering. No one understood how it climbed so high, took so much damage, and still made it home. The Luftwaffe wanted answers. The command from Berlin was simple: take apart the captured engine, examine every part, and find the secret. Crowbars cracked the crate open. The mechanic stepped back as the light touched the metal 1,200 pounds of alloy in raw strength. The double-row cylinders formed a perfect circle, shining under layers of dirt. A young engineer named Otto Hennel slid his hand along the casing, following the raised letters Double Wasp. He had worked on hundreds of BMW 801s, the engines powering Germany's FW190s. But this machine felt foreign. The cooling fins were thicker, the bolts unusually large, the exhaust system arranged in a way none of them had ever seen. Too heavy, someone scoffed. Americans make everything oversized. Hennel stayed quiet. He had heard that countless times. But he also knew that oversized sometimes meant made to endure. For a moment, the hangar fell completely silent, except for the click of tools and the hiss of kerosene lamps. Outside, snow drifted over the airfield, softening the distant rumble of artillery from the Western Front. Inside, the Germans began the careful ritual of taking apart a masterpiece they didn't yet understand. When the cowling came off, a clean metallic scent spread through the room. The first cylinder had exposed a level of precision that made even the oldest engineer stop. The threads were cut so perfectly they looked polished by light itself. No scratches, no marks, no flaws. These weren't handmade parts. They were built by an industrial power working at a scale Germany could no longer even picture. And in that instant, the mood in the hangar shifted. The jokes died away. The laughter stopped. Henschel understood that what he was looking at was not just a machine, but a physical symbol of America's industrial power. Every surface showed the story of perfected mass production, of factories running day and night without fear of bombers, and of supply lines that reached across entire oceans. He realized that every P-47 engine built in Connecticut came from a nation capable of producing 1,000 more without hesitation. When they finally rotated the engine to reveal the rear section, a soft wave of surprise moved through the group. A massive turbine housing sat behind the crankcase, larger than any supercharger they had ever encountered. Henschel leaned in, studying the twisting network of stainless steel pipes leading into the intake. "This isn't a simple supercharger," he whispered. "It's a turbocharger, powered by exhaust gas." The chief engineer frowned. That couldn't be right. Turbocharging required heat-resistant metals that Germany no longer had: nickel, chromium, cobaltol rare, all tightly controlled. Yet here it was, quietly sitting before them in captured form. The older engineers traded uneasy looks. They had spent years perfecting engines like the BMW 801 and Daimler-Benz 605, pushing them for efficiency and power. But this was raw strength created through endless resources. It wasn't elegant. It wasn't refined. It was simply unstoppable. Outside the hangar, wind swept across the frozen runways. Inside, under the weak light of flickering lamps, a German mechanic stared at a machine that shouldn't have existed and understood. Something few dared to admit: the war had already been lost long before the first shot was fired. Not by heroic pilots in the sky, but by factory workers who could turn steel into miracles faster than an empire could comprehend. If you believe wars are won by brave pilots, type 1 in the comments. If you think better machines decide the outcome, hit like. And if you want to uncover the next secret hidden in history, subscribe, because this story is far from over. In the winter of 1944, the Luftwaffe's technical bureau was drowning in bad news. Squadrons once led by seasoned veterans were now commanded by boys barely old enough to shave. Fuel supplies were rationed so severely that training flights were cut down to just 30 minutes a week. Yet from the Western Front to the skies over Berlin, a strange American fighter kept showing up bigger, heavier, and louder than anything Germany had ever faced. The intelligence officers at Adlershof called it the Thunderbolt. Reports from pilots sounded exaggerated, even impossible. "We hit it dozens of times," one message said, "and it kept flying." Another claimed a P-47 had plunged straight through a formation of FW-190s. Guns blazing, and disappeared into the clouds before anyone could respond at first. The High Command dismissed these. The High Command brushed off these accounts as excuses. No aircraft that large could possibly fight like that. But then, the wreckage started showing up. Crashed Thunderbolts were being recovered all over occupied Europe, and the more they studied them, the less everything added up. Their engines were massive. Their fuselages were built like armored safes. A single burst from a German machine gun enough to rip apart a Messerschmitt barely left marks on the American planes. Luftwaffe pilots, who once joked about the flying milk bottle. One veteran from Jagdgeschwader 26, the elite Schlageter wing, put it harshly: "They fly like anvils, and they fall on us the same way." What truly troubled German engineers wasn't only the Thunderbolt's toughness, but its altitude. On the Eastern Front, the Luftwaffe had ruled with the FW-190A, a low to mid-altitude dogfighter. But over Western Europe, P-47s were climbing above 30,000 feet, far higher than most German. Interceptors could reach them, attacking from above with terrifying speed. The reason was the engine, the Pratt & Whitney R2800 Double Wasp. At those heights, where the air thinned and cold could freeze metal solid, this engine still produced full power. The BMW 801, in comparison, struggled above 25,000 feet. Its mechanical supercharger unable to push enough air into the cylinders, the Luftwaffe's technical office opened a formal investigation. They had to find out how the Americans had achieved this. Orders went to the Rechlin Test Center to collect and dismantle any intact Our 2,800 engine recovered from downed aircraft. The hope was simple: uncover its secrets, copy them, restore balance in the skies. But by then, Germany's industry was falling apart. Allied bombers had destroyed the ball-bearing works in Schweinfurt, the aluminum plants in Norway, and the fuel refineries in Ploesti. Even if they discovered the secret building, it was an entirely different problem. Still, the investigation moved forward. Pride demanded it, and to understand what made the Americans different, one first had to understand how German engineers viewed machines. To the designers at Daimler-Benz and BMW, an aircraft engine was a masterpiece, something to be tuned, polished, and perfected by craftsmen who believed beauty and precision were inseparable. Every part was hand-fitted, every bearing inspected by sight. The result was unmatched performance when the materials were pure and the workers skilled. But it was a system built for perfection, not for a long war. In America, the philosophy was the opposite. The R2800 was not meant for master craftsmen. It was built for assembly lines. Every bolt, every thread, every gasket was standardized so that thousands of factories across the country could build the same engine with identical accuracy. Instead of relying on handcrafting, they used machines so precise that the difference between two pistons could be measured in microns. Where Germany created art, America created volume, and, in the hard math of war, enough volume eventually turns into quality. By early 1944, this difference had widened into a massive gap. German pilots were fighting on two fronts with engines that needed hours of maintenance after every sortie. American engines, however, could fly dozens of missions with only basic servicing. A single factory in Connecticut produced more R280OS in 1 month than Germany could build high-performance engines in an entire season. For the Luftwaffe, the captured P-47 engine was more than a technical puzzle. It was a question of survival. If they could understand how this massive machine worked, maybe they could find a way to counter it. That was why, when a Thunderbolt crashed near Cantiel and its engine was recovered mostly intact, it was shipped across Europe under heavy guard. The crate that arrived in Rechlin that December was more than broken metal. It represented everything Germany was losing: altitude, speed, and time. In a report to the Ministry of Armaments, senior engineer wrote, "We believe the Americans have solved the altitude problem through wasteful use of materials and fuel." He meant it as an insult, but the truth was harsher. The Americans could afford waste. They had more aluminum, more fuel, more factories, and more manpower. The Thunderbolt wasn't an engineering miracle. It was the natural outcome of an economy far larger than its enemy. Yet the Germans still clung to one final act of determination. They would open the engine, analyze it, and prove they could understand it even if they could never reproduce it. Hinchel and his team were chosen for the task because they knew radial engines better than anyone in the division. When the crate arrived, they didn't treat it like a prize, they treated it like a test of their skill. Before they loosened the first bolt, the chief engineer gave a short speech. "Gentlemen, this engine is not magic. It is metal and mathematics, and both can be mastered." The men nodded, confident. None of them knew that, within hours, that confidence would begin to collapse. What they were about to uncover inside the double wasp wasn't just better engineering. It was an entire philosophy of war made real one. That valued reliability over beauty and mass production over handcrafted perfection. If you believe victory comes from brilliant design, press 1 in the comments. If you believe it comes from unstoppable production, hit like and stay tuned, because what they found inside that engine would change everything they thought. They understood about power, altitude, and the limits of human engineering. The hangar stayed quiet, except for the steady sound of tools. Each twist of a wrench echoed like a heartbeat. Otto Henschel knelt beside the huge R2800, his gloved fingers running along the bolts that held the cowling in place. The Americans had built this engine like a fortress. Every joint was sealed, every connection reinforced. When the first layer of metal finally loosened, a breath of stale oil and burnt residue leaked into the Aragost from its final flight over France. The men leaned in under the harsh floodlights. The engine's inner structure gleamed like a piece of metal art. To a German mechanic, the layout felt confusing. The BMW 800, one that powered the FW190, was compact, tidy, and elegant, a masterpiece of efficiency. This American engine was the complete opposite. Oversized cylinders, thick casings, heavy clamps, duplicated systems everywhere. "It's ridiculous," one technician muttered. "They've built it as if weight means nothing." He wasn't wrong. The R2800 weighed nearly a ton, almost double the weight of the BMW engine. But Henschel was starting to notice something the others had not. The parts didn't just look heavy. They looked indestructible. He lifted one of the cylinder heads and studied the valve assembly. The machining was flawless. Every thread was perfect. Each gasket fit so tightly it almost seemed welded to the metal. He motioned for the chief engineer to come closer. Together they examined the finish through a magnifying glass. There were no burrs, no scratches, no signs of rough tooling. It was the kind of precision one expected from a watchmaker, not from an engine produced by the tens of thousands. "Look at how uniform everything is," Henschel whispered. Every part could be swapped with any other engine, and it would still fit. That was the first revelation. German engines were hand-adjusted, assembled by craftsmen who tuned each component until it matched. Every engine was slightly different. This American engine was something else entirely interchangeable. Built with exact tolerances and pure machine accuracy, Henschel realized this wasn't just engineering skill. Behind this engine was a manufacturing system his country had never achieved. Then came the second revelation. As they opened the rear housing, they uncovered a huge circular unit unlike anything they had ever encountered. The chief engineer stared at it. "This can't be right," he murmured. The part was a turbine huge, complex, and connected to the exhaust ports by a network of polished steel tubes. When the Americans mentioned a turbo supercharger, the Germans had pictured a small mechanical compressor. This was something completely different, a gas-driven turbine that used waste heat from the exhaust to push more air into the cylinders. Henschel carefully lifted off the casing. Inside, a ring of blades shimmered under the lamp. He touched the metal, then quickly pulled his hand away. The alloy felt strange, smooth, hard, and faintly colored. They tested it with a file. The teeth barely left a mark. One of the metallurgists whispered, "This isn't steel." He was right. It was Inconel, a nickel-chromium alloy able to survive temperatures above 700 degrees Celsius without bending. Germany had tested similar metals before, but never at this scale. Nickel was scarce. Chromium had to be saved for armor. The Americans had built entire engine systems out of it. Asterisk. Slowly, realization spread through the team. The reason the Thunderbolt could reach 30,000 feet wasn't magic, it was metallurgy. The ART 2800's turbo system allowed it to produce sea-level power, even where the air was thin like mountain frost. The turbo's exhaust lines alone stretched over 15 feet. Running through ducts that wrapped around the engine like veins, the Germans understood the design, but not how it could be built. To make one of these, the chief engineer said quietly, we'd need half the resources of the Reich. They turned to the cooling system next. Here, too, the Americans had taken a different path. Instead of depending only on air passing over the cylinders, they created a maze of baffles, oil lines, and intercoolers that spread heat evenly across the engine. It looked rough, but the idea was brilliant. The BMW 801 needed constant attention to avoid overheating. The R2800 could run at full power for hours without burning a single valve. As the night went on, the hangar filled with the smell of warm oil and sweat. Henschel's hands were coated in grease, but his thoughts were racing. Every part he removed showed the same pattern: redundancy, strength, reliability. This engine wasn't built for elite pilots or fragile prototypes. It was built for real war, where machines had to survive mud, cold, salt, air, and inexperienced crews. The Americans had built a weapon anyone could fly, anyone could fix, and any factory could mass-produce without sacrificing durability. When they opened the magneto housing, Henschel found another surprise. The ignition system was double-backed. 2 spark plugs for every cylinder, 2 full magnetos, dual distributors. If one system failed, the other would keep the engine running. The Luftwaffe, such redundancy was dismissed as useless weight. Here it was normal. They build like limits don't exist, a mechanic muttered. They don't have to, another answered. At 2 in the morning, they rolled the turbine wheel under the light and measured its dimensions. The chief engineer calculated the rotational speed, over 20,000 revolutions per minute. His pencil froze halfway down the page. At these speeds, it should explode, he said. Henschel finished the thought for him, unless they know exactly how far they can push the metal. The words hung in the air, half admiration, half defeat. By dawn, the R2800 lay disassembled across. For workbenches, its inner parts exposed like the anatomy of a creature long extinct. The Germans stood around the pieces in silence. For years, they had believed in their superiority. Better pilots, better tactics, better technology. But what lay before them on those tables forced them to face another truth. The Americans hadn't just mastered innovation, they had mastered scale. Every part of the R2800 showed that behind each Thunderbolt there wasn't just one engineer but an army of machines, workers, and factories, an entire industrial system designed to outlast any adversary. Henschel picked up one of the pistons and held it up to the light. The alloy was flawless, the surface smooth and polished like glass. He turned it over in his hand, feeling its weight. In another life, it could have been considered art. He thought about the pilots who had flown with this engine. The young Americans, who climbed into the sky, knowing back home, 1,000 more engines stood ready to replace theirs. That was a luxury no German pilot could ever imagine. He set the piston down gently and spoke in a voice barely above a whisper. "We can copy the shape," he said, "but not the soul. No one disagreed. Outside, the gray light of morning poured through the hangar doors. The war was still raging, but in that cold silence, the men around the tables understood something the front lines hadn't yet realized. The outcome had already been decided. It was written in metal. If you think victory belongs to those who innovate, press 1 in the comments. If you believe it belongs to those who build without limits, hit like and subscribe. Because the story of what happened after that morning would reveal how a single engine changed the course of the air. War forever. By the time the sun rose over Wayland, the men in the hangar were still staring at the rows of disassembled parts spread out across the tables. The R2800 had been opened, measured, and analyzed. But the feeling it left behind wasn't one of triumph. It was a quiet awe, mixed with something colder resignation. They had expected a clever trick, a secret patent, perhaps a new alloy or a hidden valve design. What they found instead was something far more intimidating, the sheer perfection of repetition. Every part, from the smallest bolt to the largest turbine blade, was marked with serial numbers tracing back to factories across the United States. Henschel picked up a connecting rod, stamped with a neat set of numbers and letters. East Hartford, 1943, Lot 128. To Henschel, it was both a signature and a challenge. Every marking on the part told the same story. This wasn't the work of a single genius or small workshop. It was the product of a vast industrial machine, stretching from Detroit to Connecticut to Los Angeles. Later that week, a detailed report from the Luftwaffe's technical division arrived from Berlin. It included a set of statistics gathered through intelligence channels. Henschel read through them in silence. The United States was producing over 850 aircraft engines per week, each one tested, built, and shipped across the Atlantic. By that winter, more than 15,000 Thunderbolts had already come off the assembly lines, and more were on the way. Corsairs, Hellcats, Marauders each, using the same R2800 engine. Germany, on the other hand, was struggling to produce 200 fighter engines a month. Most of these were built in underground factories, constantly bombed, with workers finishing parts by candlelight. To an engineer, numbers tell their own story. They speak of opportunity and of doom. When Henschel compared the figures, he realized that even if Germany somehow replicated the R2800 exactly, they would never be able to match the speed or scale at which the Americans were building them. The Americans had turned precision into a process. Germany had made it an art. One could be mass-produced 1,000 times. The other could not. Inside the hangar, Henschel started to dismantle the turbo housing to collect metallurgical samples. Lab tests confirmed his suspicions. The turbine blades contained 22% nickel and 14% chromium metals that Germany no longer had in large quantities. In 1943, the Reich's nickel stockpiles were less than half of what was needed for aircraft production. Chromium came mostly from mines in the Balkans, now under Allied control. Even if they had the blueprints, the materials themselves were out of reach. A metallurgist handed Henschel the analysis sheet. If we tried to cast this alloy with our current supply, he said quietly, it would shatter before it ever reached operating temperature. Henschel nodded. Then it isn't just the engine we can't copy, he said. It's the civilization that built it. Across the Atlantic, that civilization was running at full speed. In East Hartford, the Pratt & Whitney plant operated 24 hours a day. Workers rotated through 3 shifts, producing 2,000 engines each month, every one identical to the last. At night, the factory glowed like a furnace, powered by electricity from rivers and coal reserves that remained untouched by enemy bombs. Precision lathes shaped steel to tolerances measured in microns. Entire neighborhoods in Connecticut were built to house the workers who assembled engines, like the one now lying disassembled in Henschel's hangar. The Luftwaffe's intelligence department compiled more comparisons. The average American engine mechanic had access to over 300 specialized tools. In Germany, shortages meant many workshops had to share a single torque wrench among several teams. The Americans used alloys that contained cobalt and molybdenum, while the Reich had to rely on recycled metals taken from damaged aircraft. The contrast wasn't just in number, it was in philosophy. German engineers believed that perfection required a human touch, that every machine carried the signature of its creator. The Americans, however, believed that perfection came from removing those signatures altogether. To them, reliability wasn't an art, it was mathematics. The irony was bitter. Henschel knew that a single R2800 engine could outlast 3 BMW 801s in terms of combat hours. While the Luftwaffe's fighters required major servicing after 25 hours of flight, the Thunderbolt's engine could run over 150 hours before needing an overhaul. In the skies over Europe, that difference meant survival. He turned back to the table and studied the magneto housing again. The Germans had always dismissed redundancy as wasteful, extra weight for pilots to carry. But the Americans had built redundancy into every system, accepting inefficiency to ensure endurance. It was a philosophy born not of desperation, but of abundance. That afternoon, Henschel wrote his report. He listed technical observations in precise language: excellent alloy quality, remarkable thermal tolerance, unusual reliability at high manifold pressure. But in the final paragraph, he allowed himself a rare moment of honesty. "This engine represents a philosophy we cannot match," he wrote. "Its strength lies not in innovation, but in the industrial depth of its nation. It is as much a weapon of production as it is of flight." When the report reached Berlin, it was summarized in 2 sentences. For the Air Ministry, the American R2800 was unnecessarily heavy but highly robust. Its power was derived from wasteful design and excessive material use. Bureaucrats underlined the phrase wasteful design, using it to justify the continued focus on lighter, more efficient German engines. None of them understood that this wastefulness was the secret to survival. Weeks later, a second R2800 arrived from another wreck. The engineers unpacked it with less enthusiasm. They already knew what they would find. Still, they repeated the measurements, the weighing, the analysis. Each time, the results were the same: precision, power, and reliability produced at a scale Germany could only dream of. Henschel began keeping his own private notes, scribbled in the margins of his blueprints. "Every component is built for forgiveness," he wrote. "They expect failure, so they make sure it can survive." That single line captured the difference between the two empires. Germany designed to avoid failure. America designed to survive it. When he finished his final inspection that evening, he stood by the open hangar door and watched the snow drift across the runway. The war was now being lost in ways no pilot could see from the cockpit. Shortages, exhaustion, and an enemy whose factories outproduced Germany's by 20-1. The R2800 wasn't some secret weapon. It was the proof that technology had become the servant of economy, and economy had become destiny. If you believe the war was won in dogfights, press 1 in the comments. If you believe it was won in factories, hit like and subscribe, because in the next chapter, what these German engineers did with their discovery would shape the final outcome of the air war. By the time Henschel's report reached Berlin, the Luftwaffe's leadership was already locked in a different kind of battle one fought, not with bullets, but with pride. On paper, Germany still fielded the most advanced aircraft in the world. The Me-262 jet promised to change the course of the war. The FW-19OD was in production, and Messerschmitt's engineers were sketching designs that looked like something from another era. But behind those blueprints lay a truth no one in the Air Ministry wanted to admit. The empire had no fuel, no nickel, and no time. In February 1944, the head of aircraft development, General Feldmarschall Howard Milk, reviewed the technical brief on the captured American engine. His assistant summarized it carefully. "Their design prioritizes reliability and mass production, not elegance." Milk frowned. "So it's crude?" he asked. "Yes, sir," came the reply. "But it works." Milk closed the folder. "We will not copy crude." That sentence sealed more than a dozen decisions that would haunt Germany's air war until the end. The lessons of the R2800 were clear, but they were lessons the German system couldn't accept. The Reich's engineers believed that technical superiority meant victory. They saw the war as a battle of invention, not endurance. In America, the philosophy was the opposite. Build simple, build strong, and build so many that losing 100 didn't matter. That difference now defined the skies over Europe. As 1944 unfolded, the Thunderbolt squadrons became a force the Luftwaffe couldn't handle. With its turbo-supercharged engine, the P-47 could escort bombers deep into Germany, dive at 500 miles per hour, and climb higher than any piston-powered aircraft the Reich had. Its pilots called it the Jug, short for Juggernaut, and the name fit perfectly. German fighters that tried to intercept the B-17s found themselves hunted by these blunt-nosed monsters that refused to die. Every time a squadron returned from a mission, Allied intelligence counted the results. Thunderbolts had 7 times fewer engine failures than German fighters on similar missions. Even when damaged, they often made it home. In one case, a P-47 pilot flew more than 200 miles with a cracked piston that had split completely through the engine, still turning. The R2800 didn't just provide power, it provided forgiveness at Rechlin. Henschel's team received a tour, directive to investigate. The turbocharger adaptation for German engines was a hopeless task. Germany's factories didn't have the nickel needed to cast turbine blades, nor the machining capability to produce the delicate housings. Every attempt ended in failure. The experimental turbo on a BMW 801 melted after just 15 minutes at full boost. Another shattered under the strain of uneven casting. The materials simply couldn't withstand what the American Inconel alloys could endure routinely. Desperation started to influence decision-making. If Germany couldn't build engines that lasted, it would build engines that burned brighter, even if only for a moment. The Me-262 became the focus of that obsession. Jet propulsion was fast, sleek, and revolutionary, but catastrophically unreliable. Each Jumo 004 engine lasted, on average, only 25 flight hours before needing replacement. Pilots described takeoff as gambling with fire. One burst of throttle too fast, and the turbine blades would rip loose, tearing apart the engine from the inside. Still, Berlin insisted on mass production. The logic was tempting. If one machine could outfly the enemy, perhaps quantity wouldn't matter. But war doesn't reward perfection that can't be made in large numbers. Meanwhile, the Americans were building their imperfect machines by the thousands. A single factory in Evansville, Indiana, produced more P-47s in 1944 than Germany made of all versions of the FW-190 combined. Each one carried the same R2800, the same reliability, the same chance of survival. The Luftwaffe was bleeding to death in statistics it couldn't see. In July 1944, Henschel was invited to attend a technical conference in Augsburg, where senior engineers debated future priorities. The tone was defiant. "Our designs remain superior," one declared. "Their strength is waste. Ours is genius." Henschel listened quietly, then stood up. "Genius," he said, "requires fuel." The room went silent. Everyone understood what he meant. The genius of German engineering had reached its limit. It could no longer fuel the machines it built, nor protect them from the reality of scarcity. By autumn, Allied bombers were striking refineries in Luna and Merseburg every day. Without high-octane fuel, the Luftwaffe's piston engines lost power, their superchargers starving for air pressure. Meanwhile, the R2800 roared across Europe. Running on a steady diet of 100-octane gasoline refined in Texas and shipped in convoys too vast to stop. Every flight, every sortie, every escort mission demonstrated the same unromantic truth. Logistics win wars. In one of his final reports before the war's end, Henschel wrote a single line that would be quoted by historians for years to come. "They built engines for soldiers. We built them for engineers." It was both a confession and an epitaph. The R2800 didn't defeat the Luftwaffe through innovation. It defeated it through indifference to limitation. It was a machine that asked for no favors and offered no weakness. It revealed the entire strategy of a nation that could afford to break things faster than its enemies could rebuild them. When Berlin fell in May 1945, the remaining technical staff at Rechlin burned their notes. Henschel didn't. He packed his sketches and alloy samples into a small case, holding on to the belief that one day someone would need to remember what they had learned too late. Years later, when the Allies occupied the ruins, American engineers came across those notes among a pile of abandoned documents. One scribbled note caught their attention. "The engine is not what frightens me. What frightens me is how many of them they can build." That sentence summed up everything the Luftwaffe had failed to understand. Power was no longer about horsepower or speed. It was about the ability to endlessly reproduce excellence. If you think wars are won by invention, press 1 in the comments. If you believe they're won by endurance, hit like and subscribe, because in the next chapter, when the war ended, Henschel would finally meet the Americans and see the machine that had haunted him not in ruins, but reborn in peace. When the war ended, silence returned to the hangars that had once echoed with the shrill roar of engines and the clang of tools. Rechlin was now a graveyard. The test benches stood empty, as the blueprints scattered across the floor, covered in dust and oil. Otto Henschel stayed there for weeks, long after most of his colleagues had fled west to avoid Soviet capture. The war that had taken his youth was over, and the machine that had consumed him, the American R2800, had outlived the Reich that had tried to study it. He often walked the length of the hangar in the early mornings, stopping by the workbench where the engine had once been disassembled, like a beating heart. "They built for tomorrow," he murmured to no one. By late 1945, the Allies began dismantling what remained of Germany's aviation industry. American officers arrived at Rechlin with cameras, notebooks, and translators. They weren't looking for secret weapons. They were looking for people who understood them. Henschel was one of the few engineers who hadn't vanished. When the Americans asked him about the R2800 analysis, he told them the truth. They had learned everything they could, but nothing they could use. One of the officers smiled. "Then you were studying a mirror," he said, a few months later. Under the program that would become known as Operation Paperclip, Henschel was invited to work in the United States. He hesitated. His family had survived the bombings of Hamburg only to now live under occupation. The idea of working for the victors felt like betrayal. But the chance to see the country that could build such machines pulled him more strongly than his pride. In 1947, he arrived in Connecticut, not far from East Hartford, where the Pratt & Whitney plant still roared day and night. The first time Henschel walked through the factory, he stopped in awe. It was louder than any foundry he had ever imagined. Rows of lathe sparks flew from welding torches, and cranes lifted polished crankcases the size of cars. Women in overalls measured tolerances with micrometers. Men in aprons fitted piston rings with the precision of surgeons. Everywhere, the smell of cutting oil and hot steel filled the air. He realized that this noise, this apparent chaos, wasn't disorder. It was power made visible. When an American engineer recognized his accent and asked what he thought of the plant, Henschel paused. "It's like watching mathematics being born," he said quietly. The man laughed. "No," he replied. "It's just Tuesday." Over the years that followed, Henschel contributed to experimental jet projects. Working alongside both former German and American engineers, many of them had once tried to kill each other. Now, they compared turbine designs over coffee, trading secrets like old soldiers comparing battle scars. The lessons of the R2800 lived on in every new and June-overbuilt bearings, redundant ignition, generous cooling margins. The philosophy of durability had become doctrine. Yet, Henschel never stopped thinking about the moment he first opened the Thunderbolt's engine. In his notes, he wrote, "It wasn't their genius that defeated us. It was their patience. They didn't build for victory, they built for continuity." When Pratt & Whitney engineers asked him to review the new J57 jet engine, he saw echoes of the double wasp everywhere, the same focus on temperature control, the same obsession with reliability over elegance. He smiled and signed the report. History, it seemed, was repeating itself only faster. In 1954, he attended an air show in New York, where a restored P-47 Thunderbolt taxied onto the runway. Its radial engine roared to life with that deep, confident growl he remembered from decades before. As the aircraft climbed into the blue sky, trailing a halo of exhaust, the crowd applauded. No one around him knew that decades earlier, he had taken that same engine apart, bolt by bolt, trying to figure out how to defeat it. Watching it soar, he felt no bitterness, only a strange sense of gratitude. The sound was more than mechanical now. It was historical. It was the echo of an era when strength meant survival. Years later, long after he had retired, Henschel wrote a final letter to a former colleague who had stayed in Germany. "We learned too late," he wrote, "that perfection dies young. The machines that last are the ones built to forgive our mistakes." The R2800 had become more than just an engine. It was a philosophy, one that bridged peace and war, destruction and rebuilding. It taught that power wasn't about creating the perfect machine, but about being able to create it again and again. Every turbine that spun afterward, every jet that roared into the sky, carried a trace of that lesson. Born in the fires of 1944, if you believe history is written by the victors, press 1 in the comments. If you believe history is written by courage, press 1. If you believe it's written by engineers, hit like and subscribe, because the story doesn't end with victory. It ends with understanding. History often forgets the men who turned wrenches. It remembers the pilots, the generals, the speeches shouted over radios, but not the quiet figures bent over engines in dim workshops, trying to make sense of metal. Yet, it was in those workshops that the future was forged. Otto Henschel knew this better than most. In the years after the war, he carried with him one truth: machines don't care about flags. They reveal the truth of those who build them. In 1962, he visited a museum in Washington, D.C., while consulting for an aerospace project. There, beneath a polished glass dome, stood a restored Pratt & Whitney R2800. Engine immaculate, silent, preserved as if time itself had paused to honor it. He stepped closer, reading the small brass plate, engine from a P-47 Thunderbolt. 1944, the same year he had first opened one in Rechlin. He ran his hand along the cool metal and felt something he hadn't expected, not regret, but recognition. The guide nearby explained to a group of schoolchildren how this engine had powered the fighters that won the air war over Europe. "It was strong enough to take bullets," she said proudly. "It never quit." Henschel smiled faintly. She was right, but not in the way she meant. The engine's true strength wasn't in its horsepower or armor. It was in the civilization that built it, a civilization that understood that durability is mercy, and that forgiveness in metal can save lives. He looked around the hall and saw other relics: a mosquito bomber, sleek and wooden; a Sherman tank, squat and practical; and beyond them, the early jets that would soon rule the skies. They were all different shapes, different nations, but they shared one secret. They had been built by people who believed that the simplest design, made in great numbers, could outlast brilliance made in isolation. The echo of that philosophy rang through every rivet and bearing outside. The world had changed. The Cold War had turned engineering into a different kind of arms race. The new aircraft Henschel helped design flew higher, faster, and deadlier, but they were also more fragile, more complex, and more dependent on perfection. Sometimes, when a test engine failed on the stand, he would think of the R2800 and how it had never asked for perfection. It only demanded care. In his final notebook, he wrote, "Every machine is a reflection of its maker's soul." The Americans built for endurance, and they endured. We built for glory, and glory burned out. That sentence became his private epitaph. He never sought credit for his wartime work. He considered it a lesson learned too late and too dearly. When Otto Henschel died in 1971, his papers were donated to a university archive. Among the sketches and notes was a single photograph, a black and white image from Rechlin. 1944. It showed a group of mechanics standing around a massive radial engine under a hanging lamp. Their faces were young, serious, unaware that they were staring at the future. On the back, in his handwriting, were 4 words: "The day we understood." The echo of steel still speaks. It speaks through every jet that takes flight, every factory that hums in the night, every engineer who chooses reliability over pride. It reminds us that the machines we build are mirrors, and that progress, like mercy, doesn't come from brilliance, but from endurance. If you believe history is written in courage, press 1 in the comments. If you believe it's written in steel, hit like and subscribe. Because in every war, every invention, and every story left untold, there is always another engine waiting to be heard.